Hello students, welcome back to our second lecture of this chapter, solid, liquid and gases. Last day we have studied about what is matter, what is solid, liquid and gases and some of their properties. So today we are going to learn about some separation method, and before that we are going to know about some more about this chapter. So let's begin from where we left. About this chart, we have already studied about this chart, but let me give you some summary about whatever we have studied last day. That is the properties of solid, liquid and gases. Let's recap a bit. That is what's the characteristics of solid, liquid and gases. If we talk about the volume, then solid have definite volume, liquids have definite volume, but gases don't have any definite volume. So we can say that gases have indefinite volume. In case of shape, we can say that solid have definite shape, whereas liquid and gases have indefinite shape. Okay. And next is intramolecular force strength. We have already discussed about it in detail. So this is kind of a summary, and we already know that the solid have strong intermolecular force strength, whereas liquid have moderate, but gases have very weak intermolecular strength. Next is compressibility. Solids is almost incompressible, whereas liquid is also incompressible, but sometimes we can compress it, and in case of gases it is absolutely compressible. Next is density. Solid, in case of solid, the density is very high, whereas liquid have moderate density and gases have very low density. And the last is particle movement. If we talk about how particles move in case of solid, liquid and gases, then in case of solid, there is no free movement because all the particles are very compact in case of solid. So the intramolecular strength, which is related to this character, is also strong. We have already studied about it here. And the next is free movement and fixed in position. Solid is also position, सॉलिड का पोजीशन बहुत फिक्स्ड है. नेक्स्ट इज लिक्विड, फ्री मूवमेंट बट स्टिल अटैच्ड टू ईच अदर. एंड द लास्ट इज गैस इज फ्री मूवमेंट एंड रैंडम पोजीशन. ठीक है, यहां तक हम लोग ऑलरेडी पढ़ चुके थे. नेक्स्ट वी विल स्टार्ट विद द वीडियो which is states changes of states. Let's first watch this video, and after that we will start with our theoretical portion.
How do you think matter changes its state? Let us look at the particles in all the three states of matter. How are the particles in solid placed? Are they very close to each other, or are they placed far apart? Particles in solids are compressed and tightly bound. What holds these particles together? Is there some kind of force that keeps them tightly bound? Yes, there are forces of attraction that are at work between all these particles. These forces are strong enough to hold all the particles and thus prevent them from moving around. Now, what would we have to do in order to convert this solid matter into liquid? Hold on to your answer. Let us first look at the particles of the liquid. What about them? Do they have space in between them? Yes, there is some space between the particles of liquids. How would a solid become a liquid? By increasing the space between the molecules, correct? Seems to be the right answer. But how can we do that? The answer is heat. And do you know how heat can help? Well, we just learned that particles of solid are held together by strong forces of attraction. If these particles have to move away from each other, we must help them overcome these forces. Is there a way to do that? The answer is yes. When heat is provided, the kinetic energy in these particles increases. What would be the result of this? The particles would vibrate, and in time the energy in the particles would be more than the forces of attraction. Thus they would be able to break away from the other particles. The particles are now free to move from their fixed positions. Now you will observe that the solid matter has transformed into its liquid state. An example would be conversion of ice to water. What if I want to convert this liquid matter into gas? Will the same procedure help to convert liquid into gas? Yes, of course it will. All we have to do is keep heating these particles. They will escape all the forces of attraction that bound the particles in the liquid matter. When they start moving randomly and are free, you will see another change of matter. Liquid matter has turned into its gaseous state. An example of liquid to gas? Yes, it would be water evaporating. Can we do the reverse and interchange the states of matter? Can we convert a gas back into a liquid and a liquid into solid? It is quite simple, and we have already studied about this technique in our previous video. We applied a lot of pressure to the particles of gas and converted gas into liquid. And on further compression, liquid can be transformed into its solid form. The interchange of states of matter takes place with the help of temperature and pressure. Now we need to look at two important terms. They are fusion and diffusion. And what exactly do they mean? When a solid gets converted into liquid, we call this process fusion or melting. And what would be diffusion then? When particles of matter intermingle and mix, we call this process as diffusion. In order for matter to melt, heat is applied. And what do we need for matter to compress? Pressure, that's right. But there is something you need to know about the process of heating. When we supply heat to a solid matter, the state of matter changes to liquid, but the temperature does not rise. When does the heat actually disappear in this case? To know more about this, you must watch our next video.
So here we have learned how we can change the states of matter like solid to liquid or liquid to gaseous, or maybe in reverse like gas to liquid, and from there we can convert it into solid. Let's learn it in detail. First, we will start with how we will convert it, like the changes of states of matter. यहाँ पे क्या हो रहा है? The solid state to liquid state, and then we are converting it into gaseous state. So the first procedure will be heating it. Like if we heat solid particle, so it can convert into liquid state, and then in liquid state, if we heat it, then it can convert into gaseous state. But if we do the reverse, like if we cool down the gaseous state, then it will come back to the liquid state, and if we cool down a little bit of that, then it will come into the solid state. The states of matter are interconvertible. Like if we convert it from once, it can be converted from one particular state to another particular state. The state of matter can be changed by changing temperature or pressure. We have already seen or watched it in our video that how compression, like when how pressure and temperature actually work on that states of matter. So here is kind of a briefing, or you can say the summary how this thing is happening and how we can change it, like if we pressurize it or may we give temperature to that state of matter, this thing or this state of matter can change into another state of matter. Next is another video, that is melting and boiling, but before that we will learn about it a bit. What is melting? This is something we all know. Like if anyone asks you what is melting, we can see that if there is an ice, there is some ice in our freezer, and we take it out in our room temperature and it will melt. Simple, and that's what called melting, right? Like this is our daily day-to-day example, we can say that. So that's what happening. Like if we talk about the ice, that thing was in solid state, but if we take that out from our freezer and put it in our table or something, then because of the heat, because the room temperature is way more than that of the freezer, that's why because of that heat or that temperature, that solid state, that is the ice, is melting down to water or liquid state. So the process of change in the state from solid into liquid is called melting. Okay. And the next is what is boiling. If someone asks you to boil some water, if we want to like make tea or something, or maybe we just want some boiled water, we can say that what we will do, we will just lighten up the gas, or maybe anything we have like induction or something, and take a can or take a pot and put some water in it, and then if we give heat to that thing, then we can see that it will boil. Like the state of matter is changing here. What is like happening here is liquid is changing into gaseous form. There is a process of change in the state from liquid into gaseous state. Here if we give heat to that water in a particular pot, then it will, we can see that here is some kind of gaseous thing is evaporating. Okay, so this is what we can call boiling. Now we will watch the video we have about this melting and boiling, or melting and boiling point. What what we will call the melting and boiling point. Let's watch the video.
In our last video, I left you with an important question. What happens when we supply heat to a solid? The solid melts and gets converted into liquid, but what we saw is that the temperature of the substance doesn't rise. Where does the heat go then? The truth is that the particles of matter absorb the heat and store it inside them. This heat is in the form of kinetic energy. As this heat is hidden and it doesn't show its presence on the thermometer, we term it as latent heat. What does this heat do? Well, as we saw, this heat helps the particles to overcome the forces of attraction that bind them to each other. The temperature at which the solid changes to liquid at atmospheric pressure is called the melting point. It's easy. Temperature at which solid changes to liquid at atmospheric pressure. But let's understand it in simple terms. The melting point indicates the strength of the force of attraction between its particles. If the particles are very strongly attached, the melting point will be higher as more heat will be required. If the particles are not so strongly attached, then the melting point will be relatively lower. Do you know what the melting point of ice is? It is 273.16 Kelvin. This process of solid changing to liquid is called fusion. What is Kelvin, by the way? It's the SI unit of temperature. And 0 degrees Celsius is 273.16 Kelvin. We come to this point again. Now, what happens when we continue to supply heat after the solid has melted? The liquid will start boiling after a certain amount of heat is absorbed. And the point at which this liquid starts boiling at atmospheric pressure is called its boiling point. Understand this well. It's the point at which liquid starts boiling at atmospheric pressure. What do you think is the boiling point of water? It is 373 Kelvin. Can you convert this to Celsius? It's easy. As 0 degrees Celsius is 273 Kelvin approximately, we subtract 273 from this to get the answer as 100 degrees Celsius. That's the boiling point of water. Let's continue this process. What happens on further application of heat? You're right. This boiling water will start evaporating. Water, which is liquid, will change to the gaseous state. This is called as vaporization. But do you know something interesting? There are some substances which change directly from solid to the gaseous state. Yes, solid to gas directly. This process is called sublimation. For example, the naphthalene balls used in our houses disappear within a few days. We do not see them get converted into the liquid state. These naphthalene balls move directly from the solid state to the gaseous state. Therefore, we say that naphthalene balls sublimate. Coming once again back to the idea of latent heat. It's hidden and won't show its presence on the thermometer. We'll look at a few more terms related to this in the next video.
we will move to our next topic, that is evaporation and condensation. Here is a video, but we will look into it later. First, we will learn about what is evaporation. The first thing is when you can see like evaporation and condensation. When we will talk about it, first thing is evaporation is you can see there is a photo where you can see that there is water, but because of the heat, the water is evaporating. Here, the phenomenon of changes in liquid into vapor at any temperature below its boiling point is called evaporation. If the boiling point of that particular liquid is like way greater than that particular temperature where the evaporation or that phenomenon is happening, like if you can say there is a particular temperature of that liquid, suppose 100 degree or maybe 200 degree, but when evaporation, like when we can call it like evaporation, when the temperature below its boiling point, like is like 200 degree, but this phenomenon is happening on the boiling or that kind of liquid to gaseous state change or vaporization is happening at 100 degree or maybe less than anything like 200 अगर 180 maybe हो जाए. So that phenomenon when this state is changing, like liquid state is changing into vapor in a particular temperature, whereas the actual liquid temperature is way better than, like way greater than that particular temperature where this phenomenon is happening, then we can say that the evaporation is happening or this particular phenomenon can be seen at that particular temperature. Next is difference between evaporation and boiling. Like what exactly, like how we can differentiate this evaporation technique or boiling technique. Evaporation occurs only on the surface of the liquid, whereas boiling occurs over the large mass of the liquid. If we talk about evaporation, then there is a surface of water. Here you can see that evaporation is basically happening from this zone or this area, the surface of that particular liquid. But if we talk about boiling, then what we will do, like we are taking this water in a particular pot and then there is evaporation, there is boiling is happening from overall liquid, like overall जो इसका जो content है, जो इसका जो डेंसिटी और वॉल्यूम जो भी बोलो आप, पूरा का पूरा चीजों से जो हो रहा है, जो phenomenon is happening here, this is actually boiling, but evaporation is absolutely from the surface of that particular liquid. Only the surface particle turn into gas in evaporation, but in case of boiling, all the particles turn into gas. Like here, in case of evaporation, only the surface particle of that particular liquid is changing into gas. But in case of boiling, we can take particle, like boiling can happen from any, like here, if we talk about like, if I ask you that from that corner, is that there is a chance of have like if there is a molecule, we can find that the boiling can happen from that particular corner if there is some chance. Because boiling can happen from any particular corner or any side of that liquid substance. But evaporation can only happen from the surface particle of that substance. Next is condensation. The process by which a substance in gaseous state changes into the liquid state is called condensation. Gaseous state to liquid state. Like here you can see that if we talk about like any kind of cold drink bottle or something, if we take it out from our freezer and put it in our table, then after some time you can see that because of the outside temperature or something, because the temperature already changed, and we can see that there is some kind of watery substances is we can see in outside of that particular bottle, and this is what we can call condensation, and this is happening because the gaseous state is changing into liquid state. So this kind of phenomenon we can call condensation. Now there is kind of real life example of that word, like evaporation and also condensation, and we can say like there is another topic, that is separation. If you can give me some example of separation real life, like if you can see there is a lots of things happening around us, if you can give me an example of that thing you have seen in real life. Then give me some example of that kind of process you have seen in outside or anywhere in your home, or maybe give me an example of that in our comment section. Uh, just for your knowledge, is like if I tell you that when the salt is made, like in India, salt is made like in kind of factories or somewhere, but there is this evaporation technique actually, we can say, that is used by that particular company or maybe the people who are working there. Like how the salt is actually taken out from the seawater. Like when seawater, they take seawater in a particular jar or container or something. First, they do sedimentation, right? They like जो भी particles है, they will sediment it in the lower portion, and after that they will evaporate the salt water to get out salt from that seawater. And another thing we can talk about, like municipal water treatment. There is also another example of evaporation technique they will use. Okay, next we will come back to our video that is on evaporation and condensation. Let's watch it, and after that we will continue with another topic of that techniques.
We have seen a few methods of separating solid particles from water and now are well versed with these techniques. These methods were sedimentation, decantation, and filtration. Now let's look at one more interesting method. The method is called evaporation. Haven't we come across this method? Yes, of course. We know what evaporation is. It is simply a process in which water is converted into steam or water vapor. So changing the state of water from liquid to gaseous state is called evaporation. If you keep water in a vessel and heat it for a prolonged time, then all the water gets converted to steam. This is nothing but evaporation. But how does evaporation work for separating substances? Let's understand this with the most commonly used example of obtaining salt from seawater. We know that seawater contains various salts dissolved in it. We also know the fact that a lot of heat from the sunlight is responsible for causing evaporation of water from the water bodies present on the Earth's surface. So, can we combine these two points to get a single solution? Yes, we can. Seawater is collected in large panels near the sea. When water from these panels evaporates, it leaves behind the salts dissolved in it. The salt can then be collected, purified, and processed further to obtain the common salts that we use daily. This is how evaporation of seawater helps us obtain salts that can be processed further to gain the daily used common salt. So evaporation is very useful in separation of substances, and it's exactly opposite of condensation. What is condensation, by the way? As I just said, condensation is the opposite process of evaporation, which means converting the gaseous form of any substance into a liquid state. So in case of steam, it's converted to its liquid form, water. But how can condensation be useful in separating substances? It is used in combination with other methods for separation. Does that mean there are multiple ways of separating substances? Yes, of course. There are quite a few mixtures which do not get easily separated with one technique. There are multiple methods employed to accomplish this separation successfully. Next, let's have a look at a few examples that help us understand this.
And we will watch another video about this kind of processes. So let's watch about sedimentation process as well. After that, we will continue with our lecture.
drinking water. Zara, Zen, and Ziva were about to perform an interesting experiment in the laboratory with the help of the teacher. They were given a task of separating mud from water. But is this possible? The teacher said there are basically many ways to separate mud and water. But they were supposed to use the simplest methods among all. What could we do to separate mud and water? Can you guess what the three would have done? Let me give you a hint. Think about what will happen if you allow the glass of muddy water to sit still for a long period of time. The force of gravity comes into play. It helps the heavier soil particles settle at the bottom of the glass and thus water forms the top layer. Don't you think this is a simple trick to separate the two? That's exactly what the three kids did. Each one allowed their beakers of muddy water to stand still for a long time. When they returned, all the three beakers had mud settled at the bottom. The teacher explained that this process by which the solid, heavier particles settle at the bottom of the container, allowing the liquid to be on top, is called sedimentation. Sedimentation helps to separate the particles dissolved in water of any liquid for that matter. Now the two layers need to be separated, right? So they tilted their beakers slightly to collect the separated water. This step, in which the water or the liquid on top is gradually removed to separate the two layers, is called as decantation. In other words, separating the two layers, one settled at the bottom and the other on top, is the decantation process. So after decantation, the three were all set to show the sample of water separated from mud to the teacher. But look, the three kids found that water was still slightly muddy. It was not completely clean as they expected it to be. Now what could be done? How can the fine impurities present in the water be removed? The process of filtration came to the rescue of these kids. Next, we will see how this technique helped them obtain clean water.
So we have seen another technique, and next we will continue with our lecture. Next is freezing. Like we in real life, we can say that we are freezing, but what exactly freezing it? If we are living in a cold climate zone or something like that, like a very high altitude position, there we can see that actually the people from there is actually freezing. How? Because there is some kind of snowfall or something can happen after a particular temperature. Okay? The process by which a substance in liquid state changes into solid state is called freezing or solidification. So another name of freezing is solidification. What's happening here? The liquid state is changing into the solid state. Like if we talk about water in a particular area, like very cold zone or something, there we can see that if we like put the water in a particular glass or something, because of the temperature, that thing will change into ice. Like if in real life, if we talk about water, we take some water and put it into our freezer, then after a few hours or something, we can see that water is actually converted into ice. So here is the same thing happening, because that particular water is actually freezing. So the liquid state is changing into solid state, like water to ice. Next we will start another our next topic, that is we will start solution. So let's learn what solution is exactly. Like there is two part. If we want to make solution, there is two thing we have to add. First one is solvent and second one is solute. Now let's learn which one is called solvent and which one is called solute. If we see that picture, we can see that there is a liquid substance which is actually described as solvent, and there is some kind of solid substance which is actually called solute here. Now let's learn about it in detail. What is solution? A solution is a homogeneous mixture of two or more substances where one substance, a solute, that is the solid substance, dissolved completely in another substance, a solvent. If we talk about this example, here the solute is that powdery substance or solid substance, and the solvent is actually the water which is in that beaker. If you want to know about what is homogeneous mixture, there is homogeneous mixture is something where the same amount of two kind of like solute or solvent, like same kind of like 1:1 ratio. If we talk about a particular ratio, if we take one part of it, then we will take another part, like same amount of part of another mixture or another part as well. If we talk about like we want to take 2 spoon of it, then we have to take 2 spoon of another substance as well. Like there is a ratio, a particular ratio where both the substances are in same amount, then we can call it as homogeneous mixture. Example of solution: sugar in water. Sugar dissolved completely in water. Now if I ask about like how sugar is actually getting mixed with it, last day we have already learned that there is some intermolecular gaps between these particles. And if we talk about like water, there is some particles of water in it. If we put sugar in it, then the gaps between that particles is covered by that sugar particles. Like sugar in between that sugar gaps, the sugar is actually blend into it. Salt in water, the same way, salt mixes evenly in water. Lemon juice in water form lemonade, that is also mixture. Like if we talk about sugar in water or salt in water, there is a mixture of solid and liquid, and in case of salt in water there is also solid and liquid, but lemon juice in water, there we can see a mixture of liquid and liquid, and in case of air there is a mixture of gases. Like we have already learned about in surrounding us there is air, but that air is actually mixed. Like there is nothing like here you can see nitrogen, here you can see oxygen, nothing like that. There is a mixture of air around us, and from there we take oxygen. Air a mixture of different gases like oxygen and nitrogen. We have already discussed about it. Next is parts of solution. But before that, let's just watch the video, and after that we will continue with it. First, we will watch that video and we will learn what is actually solution and what is solute and solvent from there, and then we will explain it in detail from our PPT presentation. Let's watch the video from here.
There are three beakers on your screen, and what are they filled up with? Do you think it's water? Well, you're right. They are filled with water. Now let me add a small amount of flavored sugar powder in the first one to make a refreshing drink. In the second beaker, let me add a spoonful of lemon juice to the water. Here we make another refreshing drink. What do you think I'm hinting at? That's right. A glass of fresh lime juice is what we will get. What about the third beaker? Well, we add a gas named carbon dioxide to this beaker. Yes, you heard me right. We will add carbon dioxide under high pressure to this beaker. Do you know what I will get at the end of this addition? Well, what will be formed is known as soda, which we are very well acquainted with. It is also known commonly as carbonated water. Now, let us recollect all the things we added in water. Can you tell me the names of all the things we added to each of the three beakers? Sugar powder, lemon juice, and carbon dioxide, correct? Now let us look at the states of these three matters. Powder and flavored sugar was in the solid state, lemon juice was in the liquid state, while carbon dioxide was in the gaseous state. But as we saw, all three completely dissolved in water. Can we see the two distinct substances in any of the beakers? No, right? The substances added have completely dissolved in the water of the beaker. Let us see what water and the other substances are called in the world of chemistry. Here in these examples, the water in the beaker is called as the solvent. The substances added to water are called solutes. Why are these substances known as solutes? The reason is quite simple. The substances added are in a far less quantity than the solvent in which they dissolve. The substance in which other substances are dissolved is known as the solvent. The substances that dissolve in the solvent are known as solutes. Sugar powder, lime juice, and carbon dioxide are all solutes. Water, on the other hand, is a solvent. As we have observed, solids, liquids, and gases all dissolve in a liquid solvent. Think for a minute whether a solid would merge with another solid. Sounds unlikely, right? But yes, it's possible. An alloy is an excellent example of such a mixture. Alloys are nothing but mixtures of metals or mixtures of a metal and another element. Now, what about the final product formed after a solute has mixed with a solvent? What do we call such a substance? It is called a solution. Solvent plus solute gives rise to a solution. So, what we have in all three beakers are solutions. What are the characteristics of a solution? Let us look at the beakers to study the characteristics of a solution. As we already discussed, we cannot see the solute separated from the solvent. They have blended and formed a uniform mixture. What is such a mixture called? Can you recollect the term? Yes, we call such a mixture as a homogeneous solution. Solutions are homogeneous in nature because we cannot see two distinct substances inside a solution. Sugar, lemon juice, and carbon dioxide completely dissolve in water. The particles of these solutes find place among the particles of the solvent and blend together. Is this the only characteristic of a solution? Of course not. There are a few more characteristics of solutions which we will study in our next video. Stay tuned. So we have watched this video. So we were here.
The parts of solution, we have already learned what is exactly solute or what is solvent, but let's just recap it. The solute, the substance that dissolve, जो भी सब्सटेंस डिसॉल्व हो रहा है और एक सब्सटेंस के अंदर, that thing is actually called solute. And solvent, the substance that dissolve the solute, whatever the substance is actually dissolving some other substance, like जिसके अंदर दूसरा सब्सटेंस डिसॉल्व हो रहा है, that thing is actually called solvent. So here we can take an example of salt, which is actually called solute because this substance is actually dissolving into water. So we can call water as solvent, and if we like mix these two, we can find the salt solution because here salt and water is mixed and we can find the salt solution. Here is a simulation video for you. Let's watch it. So here, what is solution? A solution is an uniform mixture where solutes are completely dissolved in a solvent such as salt in water. Okay. First, let's watch it. Here a homogeneous mixture of two or more substances. All homogeneous mixture are solution. Here we can see salt and here is water, and here we put some salt into water and we can see that there is a salt solution formed. If we talk about some example of homogeneous mixture or solution, there we can say that alcohol and water, gaseous mixture in case of balloon like air mixture, and then if we talk about it, like here is that started again. Let's like after that we will talk like here this salt solution is formed. Then this is uniform composition. Here you can see another time there is an example is showing here. Here vinegar, if we put like vinegar, like acetic acid water, here we can find another home solution. Next is suspension and colloid. Let's like suspension is colloid is not in your syllabus. Let's move with our topics. Okay, next is characteristics of solution. Let's watch. After that, we will learn about miscible and immiscible liquid. But before that, I think the characteristics of solution, that video is very much important. So let's like watch that video, and from our next lecture we will start with immiscible and miscible liquid and soluble and insoluble substance, and after that some separation techniques like sedimentation, decantation in detail, filtration technique in detail, and also the boiling and distillation technique as well. After that some other topics are there, but before that we will just let's complete that solution or characteristics of solution, this topic first. So let's watch that video first.
What did we learn in our last video about a solution? A solution is made up of a solute and a solvent. We also learned a characteristic of a solution. Solutions are homogeneous in nature. Now let us understand a few more characteristics of a solution. A solution is also stable. What do we mean by stable? We add sugar crystals to water when we make lemon juice. Do they separate out of the solution if left undisturbed for a long time? No, they never do. Once sugar crystals dissolve in water, it is practically impossible to separate them from the solution. Can we filter the solution and separate the sugar crystals? No, filtration too cannot separate the sugar from the solution. Why is this so? That is because we have already studied that the solute and the solvent mix together and form a homogeneous mixture. They show homogeneity at the particle level. Particles of sugar are evenly distributed and they have launched themselves into the spaces between the liquid particles. Hence we say that a solution is stable. Now that we know how these tiny particles are evenly distributed, let us look at another characteristic. Take the torch and let the beam pass through the beaker which has the lemon juice. Can we see the path of light passing through the beaker? No, right? Why is this so? Well, the reason is quite simple. Particles of the solution are extremely small in size. Due to their tiny size, they cannot scatter the beam of light passing through the solution. What can we deduce from this experiment? A solution does not allow scattering a beam of light through it. Another characteristic is that the particles of a solution are very tiny, smaller than 1 nanometer in diameter, and hence they cannot be seen by a naked eye. So these were the characteristics of a solution. In the next video, we will look at a very important concept of concentration of a solution.
So that's all about today. Next day we will start with the topics I have already discussed about just before that video. Next day we will start with our next lecture, or lecture 3, about this chapter. For today, let's just revise the whole thing, and if you have any issues with any questions about this chapter or this topic from lecture 1 and lecture 2 as well, just let me know in the comment section. Let's say goodbye for today. Take care. Bye.